Welcome to the second video on section 6.1 factoring trinomials, and this will be the last video. There won't be another one because we're in the second half of the homework, where the homework has got a lot more complicated programs, complicated examples, and I wanted to set those apart from the simpler ones in the beginning. So anyway, let's start with problem number 15. And factor this trinomial. And the difference between this trinomial and the other ones is that you'll notice we've got two variables, not one, two. So how the heck do you do this problem? Well, it is still a trinomial. Anything separated by plus and minus signs is one big bundle. Let's make a big bundle here. And there's three terms. We separate the terms with plus and minus signs. But there's a trick to doing this problem. If you don't know the trick, you can't do the problem. The trick is basically forget the second variable. Just rewrite the problem without the second variable. Now, what do I mean by the second variable? Going from left to right, C is the first variable that I encounter, and then Z is the second one. So what I'm going to do is rewrite the expression without the second variable. No more Z, no more Z. I don't want a Z squared. Get rid of the Z term entirely. There you go. Rewrite it. This we can do. This looks exactly like what we had before. Okay, so what I'm going to do is I'm going to use that pattern. C squared, well, there's got to be a C there and a C there. The second thing I'm going to do is worry about the signs. What do? Put plus or minus, plus or minus. Well, what you're going to do is you're going to look at the plus 70. I want two numbers that multiply out to be plus 70. There's two ways to do that. Two pluses, two positive numbers multiply out to be positive, or two negative numbers. And I'm going to go for the negative numbers because those terms have to generate a negative middle. So this is what I'm going to do there. Next thing I'm going to worry about is give me two numbers that multiply out to be 70, add or subtract to be 17. And so there's a whole bunch of ways you can get 70. 1 times 70, 2 times 35, 10 times 7. But those numbers have to add to be 17, and I'm going to go with 10 times 7. 10 times 7 right there. And you know what? If you do a FOIL, in the background, all you're doing is a reverse FOIL. Okay? I know this answer is correct because if I do the FOIL, first terms, outer terms, inner terms, last terms, you're going to get this expression over here. But you're not going to get the original expression. Okay? So you're saying, well, why not we waste time? Well, we didn't waste time. All we got to do is say, you know, when you multiply these two last numbers, you get 70, not 70 Z squared. All you got to do to get the Z squared is tack on a Z, the second variable, to the last numbers. That's a Z there. That's a 10Z, 10Z. And you've got the answer. Because if I do outer and inner, what you'll get is negative 10CZ, okay, minus 7CZ, okay, added together, you get 17CZ. There you go. I'm going with this answer right over here. Okay, let me put that in there. C plus, was it plus? I don't remember. Let's take a look. It was minus. Ooh, I don't like to get things wrong. 10Z, C minus 7Z. Let's make sure that looks like I got my paper there. It looks just a little bad. It doesn't look very good there. I'm going to go for it. Don't second guess yourself. Go for it. Excellent. Go on to the next problem. Okay, that looks like another second two variable problem. Okay, I'm going to do two of the three. I think there's two variable problems. So what I'm going to do is close this out. Don't save that. Start off with a new sheet of paper. Some virtual paper here. File, new. Go for it. There you go. Move this over here. And so what I'm going to do is put x squared, okay, minus 4z. No, z. I got z's on my mind. xy minus 5 y squared. Okay, it's a trinomial, 3 terms. Terms are separated by pluses and minuses. That's one big bundle. It's a double variable problem. Get rid of the second variable. Okay, so temporarily get rid of the second variable. The second variable is y. Rewrite the problem without the second variable. Factor this guy, which we know how to do. Okay, x and x gives you the x squared. I worry about the signs now. I see a -5. The only way to get a negative is one's plus and one's minus. And I want two numbers that multiply out to be 5, add or subtract to be 4, and there's only one way to do that, 5 and 1. 5 and 1 multiply out to be 5. But where would I put the 5? You got to be a little careful here. I wouldn't put the 5 with the plus because that would give me a plus 5x, generating a plus term. So I'm going to put the 5 over here and the 1 over here, and that'll give me the right answer. Just do a FOIL. I'm sure you'll get it right. But the problem is, this is not the answer. It's the answer to this, but the original problem had a y squared in it, and so what you do is you just tack on the second variable to the number like that. Now, this looks, this is correct. And I think the computer will actually take x plus 1y. Let me write that down. Let me write that down here. Okay. The computer will actually take it. Okay. It's just that it doesn't look good putting 1y. I mean, why didn't we put down 1x? 1x. It's not good looking in order to mathematicians to see a 1y. So let's just get rid of that 1y. The computer would still take it, but I want to make sure you go into the math parties at UMass. They're not going to let you in the party if they see 1y. So I think that's a better way. That'll let you into the party. Check your answer. Nice work. Perfect work. So that's the same thing that we did before. So that's a two variable problem. We'll skip that. That's another 2 variable problem. We'll skip that as well. Okay, factor this entirely. So let's go jump to number 19. We'll clear it. Don't save it. File, new. Okay, there you go. Let's see what we got. Let's move this over here and write the problem down. Now, but this problem looks a little bit different from what we had before. There's no 2 variables here. There's only 1 variable. But can you see what the difference is between this problem and what we just did? Every problem that we had so far, okay, had the number 1 in front of the x squared. Okay, that's one bundle. Every problem we had so far had the number 1 in front of the x squared. 6 is now in front of the x squared. To do this problem, chances are when you see a big number in front of the x squared, you might be able to factor out that 6. In other words, take a look at 6, 24, and 72. Can 6 go into 24? Yeah, divides it evenly. 6 goes into 72 evenly. I can pull out a 6. You need to make sure that's your greatest common factor. You need to pull out the 6. You need to pull out the number in front of the x squared in section 6.2. Now, it's not always going to be the case where you can just pull out the front number. That's in section 6.3, and I'm going to have to talk about what you do there. But in this case, I can pull out the 6. And what does that mean by pulling out the 6? You divide every term by 6. 6 goes into 24 4 times. 6 goes into -72, -12 times. And now what I'm going to do is I'm going to forget the 6 for now. The 6 has done its job. I'm going to concentrate on this part here. Just this part right over here. And I'm just going to factor that part there. And we know how to factor that. We can factor that. X and X. I see a -12, which means a plus and a minus. I need 2 numbers that multiply out to be 12, add or subtract to be 4. What comes to my head is 6 and 2. 6 and 2 multiply to 12, and they subtract to be 4. I'm going to put the 6 here because it's positive, and 2. So what do I put into the computer? Okay, it's not enough to put this part. Okay, let's go off of, I think you're off the screen here. It's not enough to put this part here. Don't forget the 6 that you pulled out originally. This 6 has to come down as part of the answer. And so now that's it. You've got 3 factors here. 3 factors. It's exciting. So let's put down the 6. The 6 has to be there, the thing that you pulled out. Then I'm going to put x plus 6, and then x minus 2. Okay, check your answer, and we did it right. Look at that. That's perfect. You're going to see a bunch of these problems now. A bunch of those problems. Well, okay, this is a good problem. I'm going to do that one. Let's do that one. I don't think I'm going to save paper, though. Let's go over here. Let me just copy that. Okay, at this point, I'm going to try to save my mouse here. This doesn't look right to me. It doesn't look, and it shouldn't look right to you at this point, because every problem we've had when we did these trinomials is we put the squares in front. So let's put the squares in front. You can move the terms around as long as you keep the sign that's in front. So that's a plus 6m. So I'm going to put a 6m over here, m squared. Okay, then there's got to be a plain m term which is in the middle, and that's good. We could leave that there where it is. And then put the number, that number is plus 108, and put it at the end. And that looks a little better. And this is a 54. Okay, good. Let's factor that. That's a big bundle there. Let me push it up a little bit so you can see it. Geez, the only problems I know how to do is if we have a plane x squared. 6m squared is not a plane. It's not a plane x squared. So chances are you can probably pull out a 6. They love that number 6 in this chapter, huh? Can 6 go into 54? Yeah. Can 6 go into 108? It does, because 54 is simply twice. If 6 goes into 54, it'll have to go into 108, because 108 is twice this, so it's got to go in evenly. The long and the short of it is 6. I can pull out a 6 because it divides evenly into those numbers. And you're left with an m squared. Divide everything by 6. 9m plus 18. 18. Okay? And then, like we did over here, concentrate on the pattern that we know how to do. Okay, we're going to factor this. M and m go into the 2 terms. I'm looking at the plus at the end, minus in the middle. To get 2 pluses means 2 negative numbers, because that'll generate a negative in the middle. Now I got 2 numbers that multiply together to give me 18, add or subtract to be 9. I think 6 and 3 would do the job. Yeah, and if I do a FOIL, always do a FOIL, you'll check that middle term. But what I put in the computer is not enough to do this, because those 2 guys just multiply out to be a plain m squared term. You got to keep the 6 that you pulled out originally. Bring that down as well. So let's put that in there. Move this over a little bit so you could see it. And I'm going to punch into the computer a 6, m minus 6, m minus 3. Hit enter. Fantastic. And there's not much more to this chapter because I see 4 more problems. Let me just see the next one, what the next one looks like. Okay, so 21 and 22 look like it's the same problem. Okay, because here I see an a cubed, and here I see an x cubed. I'm going to go with 22 first. So let's start with a fresh sheet of paper. File. Oh, let's just close it. Close this. Don't save. File new sheet of paper. Okay. Okay. Move this over here. And I'm going to say 5x cubed minus 40x squared plus 75x. And that's one big trinomial, and it's a complicated trinomial because we've got cubes in the problem. This stuff is hard enough with squares. Cubes are practically impossible. Well, this problem here is not going to be impossible. Okay, because what I do is I look at all the 3 terms. Is there something I can pull out? Is there a greatest common factor? I mean, if they gave you this problem and asked you to find the greatest common factor in the first section, you look at the numbers and can, what's the biggest number that goes into 5, 40, and 75? 5. 5 divides into those numbers. Does every term have an x? It certainly does. You take the lowest power that you see, which is an x. That's your greatest common factor right there. Okay? And now I'm going to go ahead and pull that factor out. Okay? And all I do is the stuff that we did in section 6.1, just make room for 3 terms, minus, plus. I pulled out the 5 means I have 1. Okay, but don't write down 1. You got 3 x's, you pulled 1 out, you got the square. Great, I got a square term. 5 goes into 48 times. I pull 1 x out from the square, leaves me with 1. 5 goes into 75 15 times. And that's it. Now we concentrate on this part, which we can do. We've done this 1,000 times to the point where you're going to throw up. We've done it so many times. X and x gives you the x squared. Plus 15, negative in the middle means double negatives. 2 numbers that multiply out to be 15, add or subtract to be 8 would be 5 and 3. Okay, step back, look at this. This is the part where you could make an error, but I don't think we made an error because if I do a FOIL, outer and inner, minus 5x plus a negative 3x is negative 8. I think we're good. So don't forget, when you enter the answer, to put down the thing that you pulled out originally, the greatest common factor. So what I'm going to do is move this to the side, and I'm going to probably get myself over here, put this up here so that I can have a little more real estate here. Okay, so I'm going to punch in 5x, parentheses, x minus 5, x minus 3. Check my answer. Well done. Jeez, you're going to love these problems. This stuff is easy. You're going to enjoy it. You love this stuff. Okay. I'll do both of them. Start fresh. Close out of this. Don't save. File, new. Okay, move this over to the side here. I think that's all we really need. Okay. Take a look at this. Take a look at this over here. If you got it cubed, chances are you can pull something out, and I think you can. Also, it doesn't look right to me. When you have a polynomial, and I know they did this in Algebra 1, when you write the 3 terms, you go down in the order of the exponents. See, we have 3, exponent 1, and then we went up to 2. That doesn't look right. We got to list the terms in the order of their exponents. So basically, 4x cubed is where it is. That's the highest exponent. That's a 3. This is the next highest exponent. Now, when I move it, make sure you put it with the minus sign, always with the sign in front. Minus 32x. And then what we've got is the plus 60 at the end. Oh, that's an x squared. Excuse me. That's an x squared. And then a plus 60x. There you go. I'm happy. And that's a big bundle. And you know what? We got to factor that bundle. Let's see. Well, certainly we can pull out an x. We can certainly pull out an x. Because that's you take the smallest exponent that you pull out. Chances are you can pull out a 4 too. Does 4 go into 32? Yeah, 8 times. 4 go into 60, 15 times. I can pull out a 4. Okay, make a set of parentheses big enough to hold 3 terms after we pull out the greatest common factor. 4 goes into 4 once. We don't write down 1. 3. We had 3 x's. We pulled 1 out. Leaves you with 2 square. 4 goes into 32 8 times. From 2 x's, you pulled 1 out. Leaves you with a plain x here. 4 goes into 60 15 times. We pulled out the x. Now I concentrate on this part. X and X. See, whenever you have a plain X squared, chances are you can probably factor it. Let's see. I'm going to go with, you need a plus 15 minus in the middle. How about double negatives? And I want two numbers that multiply out to be 15. What comes to mind is 5 and 3. 1 and 15 could also work, but that wouldn't apply here. But because 5 and 3 add up to be 8, so I'm going to put the 3 and 5 right there. It doesn't really matter where you put it. But make sure when you enter it, not to just enter this part, you got to enter the original 4x that you also pulled out as well. So let's see if we can pull that, put that into the computer and get a green box. 4x, x minus 3, x minus 5. Check your answer. Great job. Good job. And the last problem, oh my God, x to the 8th. Yeah, right, x to the 8th. That's intense. That is intense. So I think we can probably sneak this right over here. I like the way it's written. High power, next highest, next highest. So I'm going to pull this out. 3, I don't have to move any terms around. Okay, I'm just copying it down. 63x to the 6th. Okay, that's one big bundle. Okay. How about the numbers? Can I pull out a 3? I believe we can. I can pull out a 3. 3 goes into 3, 12, and 63. I'm going to pull out a 3. Does every term have an x? Yes, it does. What's the lowest power x you see? The 6th. Okay. When I pull those out, what's left over? Now put a plus and minus here. 3 goes into 3 one time. That's good. So we had 8 x's. We pulled 6 out. Leaves you with the square. If it doesn't leave you with a square, you're doing something wrong. 3 goes into 12 4 times. Leaves you with an x because you took 6 x's from 7. 3 goes into 63 21 times. I'm liking what I see. Next thing is I just focus my eyes on this pattern, the square, x's, and numbers. I bet you we can do this. X and X. I see a negative 21. In order to get a negative number, two numbers have to multiply out to give you negative. One's positive and one's negative. I need two numbers that multiply out to be 21. Add or subtract to be 4. I'm leaning towards 7 and 3. 7 and 3 would do the job. And because this is positive, the middle term is positive, I'm going to make this the big number positive and the little number negative. And regardless, you can do a FOIL. You'll get the 4x. You got to make sure you put in your end answer the 3x to the 6th. And let's see if that's right. Okay, 3x to the 6th power. Bring it down. X plus 7, x minus 3. Check your answer. Good job. We finished up this homework. I hope you survived. I hope you enjoyed it. Next thing is 6.3, and you're going to enjoy the next 6.3 because I'm going to introduce you to an algorithm to do those problems in 6.3 that you're going to find appealing. I'll leave it at that. All right. We'll see you next video. Bye.